Okay, the final explanation for those of you who are curious to see if you got it right. Hopefully maybe you tried it on your own. If you didn't, you might want to pause now and try it. Remembering that always in the first line is your given information and the last line is what you're trying to prove. So really this is kind of indicating that we probably have two steps in there we need to fill out in order to end with an SAS. Right now we're just concluding with an SAS, an SSS, or an ASA for our justification for why the two triangles are congruent. So we know the given is AB is congruent to segment BC, and we know what was given is M is the midpoint of segment AC. So the reason, justification for this is that it's given. What are we proving? We're trying to prove that AMB, triangle AMB, is congruent to triangle CMB. And we don't know why yet, we're just trying to figure that out. So let's mark some of this information on the diagram. It says AB is congruent to BC, so we know these two segments are congruent to each other. And then it says that M is the midpoint of AC. Well, we know from previous knowledge, if M is the midpoint, hopefully you guys right away know to mark this on our diagram. We know, what do you know from that? What do you automatically conclude? What's one of the things you conclude? Hopefully you're saying to yourself that AM is congruent to MC. We know that is true. If you say this is a midpoint, then we know these two segments are congruent to each other. Why is that? Well, there's only two reasons. It's either the definition of midpoint or it's the midpoint theorem. But remember, the midpoint theorem is something to do with a half. Half the length of the original, half the length of AC equals AM. This doesn't have anything to do with half. This says these two segments are congruent. Therefore, it's the definition of midpoint that allows us to make that statement. So I need one more piece in here. Well, I don't know anything about these angles. I don't know anything about that this is a 90-degree angle. I don't know that yet. Some of you might be saying, oh, I know that's an isosceles triangle and therefore they're base angles. But no, we don't. We don't know that yet. We haven't learned anything that says that yet. But we do know that BM is part of both triangles. It's a shared side. So we know that BM is congruent to BM. This side is the same side in both triangles. Why is something congruent to itself? It's the reflexive property. Okay, so reflexive is another one that's kind of common in some of these proofs. Reflexive, it's in both triangles. So now we know AMB is congruent to CMB. So why is that? Well, what do we have here? The three pieces are S, S, S. So side, 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 side. So that's it. Definition of midpoint was huge. It allowed us to get the third piece, right? It allowed us to get this, or sorry, the second piece, I guess, and then the fact that this is reflexive, it's in this each triangle, was our third piece to get side, side, side. So you should be able to see those pieces in the triangle. Here you can see a side, and an angle. So it's SAS. Here, and the one above that, we can see an angle, and a side. So it's probably ASA. We knew it had to be because those are the only ones we've studied so far today. We've studied ASA, SAS, and SSS. But we're going to move on to learn other theorems that will prove triangles congruent, so you're going to have to be a little more careful as you move on. If you are not understanding this stuff, well, we have a quiz. We have one more class, and then we have a quiz in the third class. So you need to come in, see one of those geometry teachers so you can get your questions answered. Otherwise, the whole semester, it's just going to start spiraling a little bit out of control. So make sure you stay on top of things, make sure you're doing your practice problems, your homework, and you're asking questions. We're here for you. We want to help you. See ya.